flow than the Silver
We
Springs?
we think it's pretty obvious that Rainbow and Silver basically are in the same spring shed. And Rainbow is 10 feet lower. The outlet from Rainbow is 10 feet lower than the outlet from Silver, because it's closer to the coast. You know how the topography slopes. And so as the aquifer levels have come down, Silver's flow obviously has been going down, but water that used to come to Silver, now it's shorter distance for it to go to Rainbow, because Silver's the aquifer's too low for the water to come to Silver. It can go to Rainbow now. And so we call it pirating. It's not like Rainbow's doing it on purpose. But the flows in Rainbow would be much lower too if they were at the same elevation. They would both come down together. They're not. They're at different elevations.
On the slide you pull, what's the red wedge you pull in?
Sorry?
I can't see it, the red.
Well, I told you it was out of book. I can't even read it. This is public supply. This is private domestic self-supply. I think it's commercial. Now here's commercial. This is probably industrial. Or no, it's probably cooling. It's probably power plant cooling. They have power plants there in Lakeland. So I think that's what they actually use fresh water to cool that power plant. Most power plants are along the coast and they use salt water for cooling, but some use surface water and one or two use groundwater. That's what that is. So green is agricultural, and so Alachua County, where I am, almost half the use is agricultural. The blue is public supply, that's Gainesville, and we have the Deer Haven power plant, and it uses groundwater for cooling. So, any other questions? Yes.
On the next slide, so do you attribute the decline, because it declined a couple of different times, to like the rise in population or
Well, these
rainfall,
solid
or?
lines are the long-term averages. So the annual variation is noisy. It's noisy because, we had 70 inches of rain in 2017,
Right.
and we have some years we have 50 as the average,
Right.
and then some years we have 38 inches of rain. So that as it rains different amounts, the spring flow goes up and down, because rain instantly around here on the sandy soils goes into the top of the aquifer, and within less than a day, a high rainfall event will show up as increased flow at Silver Springs, because you basically build up the pressure in that bucket that's
Right.
feeding that spring. So that what you really have to look is the trends, and the trends are very obvious. This is it's called low S. It's a way of statistically smoothing. There are actually daily data behind these lines. We have daily estimates of flow for the springs. So those annual averages are interesting. Like here you have a very low year for Silver, and of course Rainbow is low too, because it rains. It doesn't rain exactly the same everywhere.
Right.
It rains different amounts. Yes, ma'am.
So the solid line is the springs water. That doesn't have to do with,
These are just the flow of the springs. These are the estimated, what we call discharge, or outflow from the springs. These are in cubic feet per second, and a cubic foot per second is 0.64 million gallons a day. So it's actually 800 cubic feet per second is about 500 million gallons a day. And Silver has gone from an average of 820 cubic feet per second down to an average of about 350.
but the up and down is the rainfall.
No, the rainfall's not on this graph.
Oh.
And I've got other
This
graphs
is
I
the
can show you.
main-
These are just the flows of Silver Springs flow and Rainbow's long-term average. They're both going
The rain
down.
has something to do with it.
What?
Oh, yeah.
Rainfall has a lot to do with it.
Well, yeah.
Yeah, and so the highs, when you have high flow, those are years of high rainfall, or following years.
Got a good hurricane.
Yeah, and that's what they are. And so there was a drought in 2001 and 2 that led to very low flows in both systems. But then in 2012, we had another major drought, and it was broken by Tropical Storm Debbie, if you remember that. And the flow in Silver comes right back up. But that doesn't change the average. If you look, the low flows for Rainbow are these lower red dots. Well, they're getting lower all the time. And the low dots for Silver are getting lower all the time. It's just, we're in a wet year-and-a-half period right now. We could easily go into a drought. Nobody can predict that right now. They're not predictable. And if we do, Silver's flow will go down again, it'll turn green again, and the algae will come back. So I'm just trying to give you a real abbreviated description of these things. If you want to learn more, I actually have a couple copies of my book I can sell you, but it's all summarized in that restoration plan. You can get all this information from that plan. And so the other issue with silver is it's terribly polluted with nitrogen. The state has developed a numeric nutrient standard for nitrogen for springs. And that standard was set to avoid algal blooms, basically proliferation of algae in the springs, an unhealthy ecosystem, basically. And it turns out that everything we're putting on the sandy soils, a lot of that, not all of it by any means, but a lot of it ends up in the ground. The state's average, the estimate for silver is 13 million pounds a year of nitrogen is being contributed to the land surface in the spring shed for silver. 13 million pounds of nitrogen. You get, I should be able to tell you, but I don't know exactly how many dump trucks that is. And the amount that's coming out of Silver Springs is about 15% of that. It's about 1.7 million pounds a year is actually coming out of Silver Springs of nitrogen. And that is way above the standard. The state has said that needs to be reduced by almost 80% to meet the water quality standard for Silver Springs. That's how far they let it go. And this map is a map of the groundwater nitrogen levels throughout Florida as of 2004. And you can see blue is what all the groundwater in Florida was historically. And now we've contaminated a very large part. These are the areas where the aquifer is really vulnerable to fertilizer and pollutants move from the ground surface into the underground. It basically places where there isn't clay. If there's clay in areas like in eastern Alachua County, eastern Marion County, where you've got the Ocala forest, the nitrogen doesn't make it into the aquifer, but it does everywhere else. And this is down in Polk County. Now these numbers are way above. The spring standard's way down here. The human health standard is right up here at the red. And everything in between is supposed to be safe for humans, but it turns out it's not. When you start looking at the evidence from all around the country, this is happening all over the United States, not just in Florida, where they've done epidemiological studies. It turns out that a concentration around 2, which is right up here, increases your risk of cancer by 3 to 5-fold for urinary cancer, bladder cancer, thyroid cancer, and for birth defects. And that's just, oh, well, we're not going to lower the standard because that's just epidemiological research, you know. But that's what's happening. We've got large areas of the state are orange or red, and silver's approaching that. In Marion County, about probably 10% of the wells that are sampled are above the red. They're in the red part. So depending on where you get your water, you may be drinking water with those high levels right now. But this is a blow up of Marion County. There's Silver Springs. This whole side of the county, this is Ocala. There's over 40,000 septic tanks in Ocala, I believe is roughly the number. And that's contributing to this. And then agricultural inputs are contributing to this. In fact, the numbers have been estimated. This is the concentration of nitrate in Silver Springs since 1900. Was right down here. It passed this state standard. Well, there wasn't a standard back then, but the area that's the standard that was passed back in the 40s, and the nitrate levels are still going up in Silver Springs to where they are now, which is about 2 parts per million. Getting close to the point that is implicated in an increased risk of cancer. Yes, sir.
Is surface water pumps, wells, surface water wells, are they as high in the nitrogen content as the deeper wells?
Actually, the ones that have the highest concentrations are the ones that are shallowest, because the pollution is coming from above. The shallower the well, the higher the nitrate will be typically.
Even in a forested area?
Yeah, well, in a forested area, it's where you have the lowest nitrate because there's no fertilization going on and no animal. I don't know if I've got the numbers in here. Yeah, here you go. This is a breakdown that the state produced as part of their restoration plan for silver. They think that as much as a half of the nitrogen that's coming out of Silver Springs is coming from septic tanks. But if you add fertilizer, crop fertilizer, and cattle and horses, you actually get about half of it is from agriculture. And so this is not just farmers, it's not just urban people putting fertilizer out on the lawns, it's everybody. Everybody that's contributing extra nitrogen, and we all contribute some in our waste. And that goes to wastewater treatment plants, which also are part of the problem. And of course, septic tanks are just our own little private wastewater treatment plants. They don't treat the waste at all. All the nitrogen basically you put in a septic tank comes out and infiltrates into the ground in this kind of area. So we're all responsible for this, but the only way to correct it is for everybody to do less in terms of their load. And that means urban fertilizer should be greatly reduced. It should be reduced by 80%. But it also means agricultural fertilizer. If you don't reduce agricultural fertilizer by 80%, then urban is going to have to be taken away completely, and we're going to have to connect every septic tank. I mean, everybody has to be involved. It could be very expensive to solve these problems, but it doesn't have to be. So here's a picture of silver in 2009, the kind of algae that was growing on the eelgrass there. That's not a good picture and not a pretty sight. And so one of the things the Florida Springs Institute is doing, we're moving the science forward as rapidly as we can to try to get the state to clean these things up better. One of the things we're doing is we've created a blue water audit. So for the whole Springs region of Florida, 25 million acres, we've taken every property over 5 acres and estimated its groundwater consumption on that property, the owner of that property, and its nitrogen footprint on the aquifer. So we've basically been able to do that through the magic of Geographic Information System, GIS technology. It's amazing, all these overlays of existing data. We took all the property records. We actually have several million properties, but over 300,000 are 5 acres or above. We've assessed towns like Ocala, and I'll show you some data in a minute. We've taken the vulnerability of the aquifer in these areas. We've used the FDACS, the Florida Department of Agriculture, has a database of irrigated agriculture, and we've taken land use data, and we put all those things together into maps that you can find on our website, our bluewateraudit.org website. And this is a map for the nitrogen loading throughout the whole Springs region. The Springs region goes all the way down to just north of Lake Okeechobee and goes all the way out in the Panhandle. And in that area, the estimate from this Blue Water audit is about 26,000 tons of nitrogen a year. That's, multiply that times 2, it's over 400 million pounds a year of nitrogen is actually getting to the aquifer. Did I do that right? Maybe 4 minutes now. I think you can do 2,000 times that. Maybe 40 million tons is getting to the aquifer. Anyway, this is the actual nitrogen that's getting to the aquifer, and you see that there's areas, once again, where that groundwater map showed that the areas of highest impact are these karst areas in like western Marion County. And if you looked up close in Marion County, you can see the actual parcels here that are contributing to these loads. And anything that's this dark orange-brown is a severe loading, much, thousands of times higher than the average loading in minimal areas like in eastern where the Ocala National Forest is very light loading. The nitrogen's coming out. This Silver Springs is right here, and this is Silver River. That's the Ocala River. Nitrogen's coming from mostly these agricultural areas, as well as the city of Ocala. This is the average footprint for the whole city. It's moderate, and that's mostly from septic tanks, and then some lawn fertilizer.
What do you think is the severe?
The severe, those are individual farms that have very high loading. It's usually irrigated farms where they're growing row crops, or and not so much dairies in your area, but up in the Swanee River area, we have very large animal facilities where they've got thousands of cattle and dairies and feeding operations now. In Marion County, horses are a very large component of it, and same with Rainbow. So horses, I know you're interested in horses.
Right. But
dealing with manure is an issue, as you know. And that is one of the sources. Yes?
So on your map, like South Florida was not on there, so what does it look like compared to?
South Florida is a different aquifer.
Yeah.
It's not the Floridan, they have the Biscayne Aquifer,
Okay.
the Anastasia Formation, there's a different aquifer in far west Florida. Those areas do not contribute to our spring flows. There aren't any springs in South Florida. There used to be, Miami Springs, Coral Springs,
Right.
those springs have been gone for a long time.
But I mean, if you had compared them side.
I showed the map for nitrate, and you can see, groundwater nitrate, you can see this map goes all the way to South Florida. They don't have nearly as much contamination.
Yeah.
Because their aquifer,
Well, then you got the
their
Everglades
aquifer's not
area.
vulnerable down there. There's a lot more clay. This aquifer here, around the Biscayne aquifer around Miami is vulnerable, but it's not in agriculture very much anymore. Most of the agriculture's out here in the wetlands, the Everglades agricultural area, and along Kissimmee.
So it's red.
And those are wet areas that the nitrogen doesn't get into the groundwater in those areas.
And what about Lake Okeechobee?
It's clay as well as wetland areas have natural denitrification that is actually removes the nitrogen. Lake Okeechobee is very contaminated with phosphorus from agriculture,
Right.
terribly contaminated.
And nitrogen.
Yeah.
And nitrogen to some extent, but it's.
So, but that goes out to the ocean.
Lake Okeechobee goes out in the rivers, and it turns out the amount of nitrogen going out those rivers is less than what's coming out of the Swanee River. The
Really?
Swanee River up here
Really?
has got more nitrogen coming out than both the St. Lucie and the Caloosahatchee combined.
Wow.
So we
Wow.
have the biggest groundwater nitrogen issue in this part of Florida, in our Springs region, and that's why we're seeing so many of our springs are contaminated.
Huh.
Well, you said Miami had Coral Springs.
They had some springs. They
Did
were
they just
not
dry
artesian
up?
springs. Yeah, they basically were paved over.
Paved.
But
Like
they weren't
Shannon.
really artesian springs, they were more seepage type springs, which,
Mhm.
there are seepage springs everywhere, wherever there's a hill and you have a slope, and then clay layer at the bottom, the water runs out at the base of the slope. And those are called seepage springs, but our artesian springs are springs that are coming from an underground aquifer that's actually under pressure.
Right.
And the Florida aquifer is under pressure for reasons I can explain to you later. So that's a blow up of we call this the nitrogen footprint. And this is the water footprint for that area, the Springs region, is 25 million acres. And you can see here, there's Silver Spring. Ocala is the biggest footprint in terms of water use. And this immediately around Ocala, and then there's various farms that have irrigation that have high uses. And then you get down near Orlando, they've permitted close to 1 billion gallons a day of groundwater use right around Orlando. They've permitted that much. And they're pumping, as I showed you before, over 250 million on average.
Now, Bob, is this recent?
This is based on the most recent data, it's the last decade, basically. Yeah. This is,
So Adena Springs isn't pumping that much out about near Fort McCoy, it doesn't look.
no, they're probably not pumping anything. I don't think they're doing very well over there. They got their permits, but that doesn't mean they're using the water. I don't know how much they're using. I can't tell you, but I will be able to tell you, I'm putting together a database of every permit that's got pumping data, and in a few, maybe another year, I'll really have that at my fingertips. It's very hard to get that information out of the districts right now. John?
I'm just curious, at DEP, are there people similar to you that are responsible for compiling this information, analyzing, putting it all together one big picture? Or is it the case because there's 5 different water management districts, they only look at their own section and there's never a general overview like you've been doing?
They stopped doing groundwater nitrate maps about the time I started doing them. I went to all the districts in the DEP to try to get them to do a statewide map of groundwater nitrate levels. They did provide their data to us, but they weren't willing to do the maps. They had been doing some before that, just individual water management districts, but there was, to find a statewide map, you'd have to probably go back to the 50s or 60s.
Wow.
No, they are not doing this. They are not, they're assessing the nitrogen loads. That circle, that pie chart is theirs, from the BMAP report for silver.
Where do they get it from?
Well, they've got a plan. You can go find their plan, 100 pages long. I don't remember how many pages, and it says, here's how we're gonna deal with this. And the plan deals with about 20 or 30% of the problem. And it's all pie in the sky stuff. There's no money allocated for it, or very little money. It's the appearance of doing something without actually doing anything.
But where did they, if they're not doing the study, the nitrogen load, where did they get their data from?
Well, they did one for just the Silver Spring spring shed, and they didn't even do the whole spring shed, they carved out a smaller area. Those of you that went to the BMAP
Right.
meetings with me saw that I complained, they did about 800 square miles, and the actual spring shed for Silver is about
Yeah.
1,300 square miles. And they carved out an area of 800 acres and said, well, this is the natural boundary, we're just gonna deal with this area, because anything outside here is more than 100 years travel time. It turns out it's like a few months travel time when they actually did the diatrese. It's false science. I'm not saying that good scientists don't exist at the districts, but they're not allowed to do good work.
They haven't been.
It's a very sad time where the public has to get up and act.